Hello, ladies and gentlemen. It's Matufaro here. Welcome back to my space. This is the third video in the series of videos where we explore ways to evaluate the limits of some certain functions without the use of the L'Hopital's rule of series expansion. In the first video, we saw how to use trigonometric identities and the basic fact to compute the limit of this function without using the L'Hopital's rule. We get pi squared over 2. And in the second video, we use the same toolbox, we say the same identities to evaluate this as 1 over 2, totally avoiding the use of the L'Hopital's rule. In this video, we'll see how to compute this third limit on the problem set without also using the L'Hopital's rule. So let's get right into it without wasting much of our time. So as usual, the first thing we'll check is if we can do it by direct substitution. So if we put in x equals to pi, what do we get? We get pi times cos pi plus pi over sine pi. And since cos pi is equal to -1, we have pi times -1 plus pi all over sine pi, which is equal to 0, because the sine of any multiple of pi is equal to 0. And this is equal to minus pi plus pi over 0, which is equal to 0 over 0. This is not factorizable. We cannot rationalize. And we cannot also use the trick we've used in the past two videos, which is to multiply by conjugates, because it is not like either of those two. So what do we do? So that's a beautiful question. So because we want to make use of the fact here, we have to make sure that we have something that that goes to 0. So the first thing we're going to do is to make some transformation. And what kind of transformation are we going to make? It's the one for which it changes the limit to 0. So as x goes to pi, so we can use let y be equal to x minus pi. So that means as x goes to pi, our y will go to 0, because if x goes to pi, this becomes pi minus pi. That is equal to 0. So if we do that, then x is equal to y plus pi, or pi plus y. So it means we can replace all the x's in the expression with y plus pi. So let's do that. So it means we have our equation, our function changed to y goes to 0 of y plus pi times cosine of y plus pi all over sine y plus pi. Now, where do we go from here? We recall the properties, the periodic property of the sine and cosine function. So sine pi plus x is equal to negative pi sine x, and cosine of pi plus x is equal to negative cosine of x. So it doesn't matter whether it's x or y, the result remains the same. It's an identity. So it means that we can rewrite this as the limit as y approaches 0 of y plus pi of negative cosine of y. Let me put that in braces or square bracket. Cosine of y plus pi. Okay, all over negative sine of y. Now we are making progress. So we can split this into the limit as y approaches 0 of, so if I open up the bracket, I get negative y cos y, then minus pi cos y plus pi all over negative of sine y. And if I pull out, if I factor pi in one of them, so this is the limit as y approaches 0 of negative y cos y plus pi into bracket 1 minus cos y all over negative of sine y. And here we can make use of the negative signs there. So this becomes negative. So the negatives cancel, or if we factor out the negative sign in the numerator. So we have y approaches 0 of y cosine of y plus, or that will be minus pi of 1 minus cos y all over sine y. Yes, are we still on track? So we have negative y cos y and minus pi cos y plus pi. And if we factor out the negative sign, we'll be left with negative. So the negatives will cancel. We're left with y cos y minus pi into bracket that. Okay. So that makes sense. So from here, we can split it into two fractions. So we have this to be limit as y approaches 0 of y cos y over sine y minus pi into bracket 1 minus cos y over sine y. So now we can split this into two limits. So which is the limit as y approaches 0 of y over sine y cos y minus pi of the limit as y approaches, pi is a constant, so I can pull it out. Then 1 minus cos y over sine y. Interesting. So you observe that I have rewritten the first fraction in a funny way, and that is because I can see that I can break this down into limit as y goes to 0 of y over sine y times the limit as y goes to 0 of cos y. And the second one, for me to be able to evaluate this limit, ordinarily when I plug in y is equal to 0, I will get, let's look at it on one side, we'll have 1 minus cos 0 over sine 0, which will still be 0 over 0. So to deal with that, this is almost like what we've done in the first two videos. So I can actually multiply by the conjugate of 1 minus cos y. So this is going to become pi, so minus pi limits as y goes to 0 of 1 minus cos y over sine y times the conjugate of 1 minus cos y, which is 1 plus cos y over 1 plus cos y. So the first part of the limit is settled. Why is it settled? So this first one, this one that I have highlighted in blue, is exactly what we have in the fact. So if limit of sine x over x as x goes to 0 is 1, we can also turn it upside down. The limit of x over sine x as x goes to 0 is also going to be equal to 1. It doesn't change. So therefore, this first part is 1. And the second part, we can just plug in 0. So that is cosine of 0 minus pi times the limit as y goes to 0 of the difference of two squares of this numerator, that gives us 1 minus cos squared y over sine y. I've said it in the last video that we do not need to expand anything in the denominator. 1 plus cos y. And using the Pythagorean identity, we know that 1 minus cos squared y is equal to sine squared y. So this is equal to 1 times 1. Okay, let me use parentheses. Minus pi, then limit. You can see until I make the substitution, direct substitution, I would always drag along the limit expression. So limit y goes to 0 of sine squared y, which is actually sine y times sine y, over sine y into bracket 1 plus cos y. So then sine y will cancel out one of the sine y's in the numerator. So this is 1 minus pi, the limit as y goes to 0 of sine y over 1 plus cos y. Now we can plug in y equal to 0. That will be 1 minus pi times sine 0 over 1 plus cosine of 0. So that is 1 minus pi times 0 over 1 plus 1. And of course, you know that 0 over anything is 0. That is 1 minus pi times 0. And 0 times anything is 0. That's 1 minus 0, which is equal to 1. So, as we have seen, we have totally avoided the use of the L'Hopital's rule or the series expansion, and we used the Pythagorean identity. The only fact that we use there is that the limit of sine x over x as x approaches 0 is equal to 1. So if there are any questions or any reservations or anything you'd like me to clarify about this particular question, do not hesitate to drop your comments below. And that is the end of this third video. Until we meet again in the next one, enjoy mathematics to the fullest. Bye.